Hello, dear students. My name is Bankeswar Panigrahi, faculty, BCA department, Chikiti Mahavidyalaya. So in our last topic, we have covered about what is Hdlc and what are the different types of transmission modes are there in Hdlc, and what are the frame format that is used in Hdlc, and the different fields available in the frames of Hdlc. Okay, so today we are going to discuss about the high level data link control protocol part 2, that is control fields of Hdlc. What is that? Hdlc control fields. So first, why we use the control fields, we have to discuss. So the control field determines the type of frame and defines its functionality. As we have discussed in our previous topic or in our last session, that Hdlc is having three types of frames, that are I frame, S frame and U frame, and the control field determines the type of frame, that means which type of frame is it, either I frame or S frame or U frame, and it defines the functionality of that particular frame or its functionality. Okay, so what the control field defines? The control field determines the type of frame that is used and defines its functionality. Okay, so here it is given that the control field determines the type of frame and its functionality, as I have told you, and the format is specific for the type of frame as shown in the following figure. That means the different type of frame format is having its specific control fields. Okay, so this is the diagrammatic representation of I frame, S frame and U frame. That means information frame, supervisory frame and unnumbered frame. Okay, so these are the different types of fields that is given here. That is, first field is 0 in I frame, and in S frame first two field is filled up with 1 and 0, and in third U frame the first two field are filled up with 1 and 1. Okay, then N of S, N of R, N of R code. So we will discuss all about the different types of frames and their control fields one by one. So first we will discuss about the I frame. Okay, so basically, listen carefully, basically I frame are designed to carry user data from the network layer. Okay, so why we are using the iframes? Iframes are designed to carry the user data from the network layer. So the first bit, so here the first bit defines the type. That means if the first bit is 0, then we will define it as iframe. If the first bit of the control field is 0, that means the frame is in iframe, and the next three bits, this is 1, 2 and 3, the next three bits are called as n of s. That defines, this n of s defines the sequence number of the frame, but in the extension format in which the control field is 2 bytes, this field is larger. Okay, so what it defines, n of s defines, the n of s defines the sequence number of the frame. Okay, so what are the different sequence numbers are used in the frame? Okay, and the last three bits, okay, last three bits, these are the last three bits, that is called as n of r, or it is represented as n of r, that corresponds the acknowledgement number when it is used. So it is used for the acknowledgement number. So n of s is used for the sequence number, and n of r is used for the what? The acknowledgement number. Okay, what is that? Acknowledgement number. So the middle part of n of s and n of r, that is represented as p by f, okay, p slash f, it is a field which is having a single bit, okay, which is having a single bit. So its main motto is it is used for dual purpose. It has meaning only when it set bit equal to 1, and can mean for pull or final. Okay, so how we can know that? We will know that the frame is an iframe. If the first bit is 0, then we have to know that it is in iframe, and the n of s defines the sequence numbers, and the n of r defines the acknowledgement numbers, and the p by f or p slash f, it defines pull or final. Okay, what is that? Pull or final. So it means that pull or final means pull when the frame is sent by a primary station to a secondary station, and final means when the frame is sent by a secondary station to a primary station, that is called as final. That means here pull means the frame is sent by a primary station to a secondary, and the final means the frame is sent by a secondary to a primary. That is called as pull or final. Let me go to the notes about the iframes. So here it is given to the about the iframes. Iframes are designed to carry user data from the network layer. In addition, they can include flow and error control information, that is called as piggybacking. The subfields in the control field are used to define these functions. What is that? The first bit defines the type, as I have told you. If the first bit of the control field is 0, this means the frame is in iframe. The next 3 bits called n of s, which is defined the sequence number of the frame. Okay, the sequence number of the frame. Note that with 3 bits we can define a sequence number between 0 and 7. Okay, that means 8-bit format. Okay, that is 1 byte format. But in the extension format, in which the control field is 2 bytes. Okay, so this field is larger. So the last 3 bits called as n of r correspond to the acknowledgement number. That means either it is a positive acknowledgement or it may be a negative acknowledgement when piggybacking is used. That means when the user data is passed from the network layer, either there are 2 possibilities are there. Either it may be passed or it may not be passed or may not be reached. When it is reached, then it is given as a positive acknowledgement. When it is not reached, then it is given a negative acknowledgement number. Okay. Next, the middle part of NFS and NFR is called the P/F bit, and the P/F field is a single bit with a dual purpose. As I have told you, it is used as dual purpose, that is pull or final. Okay. Here it is given. It has meaning only when it is set bit equal to 1 and can mean pull or final. Okay. It means pull when the frame is sent by a primary station to a secondary. That means when the address field contains the address of the receiver. It means final when the frame is sent by secondary to a primary. So this is all about the what iframe, that is information frame. Next, again we may go through the S frame. So unlike iframe, how we can identify a frame is an iframe? If the first bit of the frame is 0. Okay, so unlike that, how we can find out the frame is in S frame? If the frame having the first 2 bits is 1 and 0. Okay, so S frame, the full form of S frame is supervisory frames. And why it is used? The S frames are used for flow and error control whenever piggybacking is impossible. Okay, whenever piggybacking is impossible. Okay, so S frames, another point is there, S frames don't have information fields. Okay, S frame don't have information fields. If the first 2 bits of the control field is 1 and 0 or 1 0, that means the frame is in S frame. Okay, so the last 3 bits, as of similarity of iframe, okay, the last 3 bits are n of r, corresponds to the acknowledgement number or negative acknowledgement number. That means positive acknowledgement or negative acknowledgement as similar as to the iframe. So n of r in the S frame also defines the positive acknowledgement number and negative acknowledgement number. Okay, and the 2 bits, these are called as code bit. It is used for to define the type of S frame itself. So what are the type of S frame itself? With 2 bits we can have 4 types of S frames anomaly. So what are the 4 types of? That means the S frame is having the code field that defines the 2 bits code field defines what type of S frame is it. That means S frame are of different types and the code field defines what type of the S frame is it. Okay, so what are the different types of S frames are there? There are 4 types of S frames are there. First is receive ready, second is receive not ready, third is reject, and fourth one is selective reject. Okay, so first is receive ready. So how we can know that the frame is in RR, that means receive ready, if the value of the code subfield, this is called as the code subfield, the value of code subfield, listen carefully, if the value of the code subfield is if 00, then we can consider it as a RRS frame. Okay, so value of the code field if 00, then we can consider it as a RRS frame. And if the value of the code subfield, that is 1 and 0, then we can consider it as a RNR, that means receive not ready S frame. And if the value of the code subfield is 0 and 1, then we can consider it as a reject or reject S frame. Okay, and if the value of the code subfield, if it having 1 and 1 or 1, then we can consider it as a selective reject S frame. Okay, again, if the code subfield is having 0 and 0, then it is considered as a receive ready S frame. And if the code subfield is having 1 and 0, then it is considered as a RNR, that means receive not ready S frame. And if the code subfield is having 0 and 1, then it is called as reject, that means REJ frame. And if the code subfield is having 1 and 1, then it is called as selective reject S frame. Okay, so how many types of S frames are there in based on the control fields? That there are 4 types of S frames are there. What are they? RR S frame, RNR S frame, REJ S frame, and SR S frame. Okay, selective reject S frame. Okay, so this is all about the S frame. We may go through the notes about the S frame. So here it is given control field for S frames. Supervisory frames are used for flow and error control whenever piggybacking is either impossible or inappropriate. If the first 2 bits of the control field is 1 and 0, this means the frame is an S frame, and the last 3 bits called N of R, that is corresponds to positive acknowledgement or negative acknowledgement number depending on the type of S frame, and the 2 bits called code is used to define the type of S frame itself. That means what are the different types of S frames available, and what the current used frame is, what type of S frame it will indicate. With 2 bits we can have 4 types of S frames as described below. As I have told you, what are they? First is receive ready, second one is receive not ready, third one is reject, and fourth one is selective reject. So one by one let me go through the notes. If the value of the code subfield is 00, as I have told you, then it is an RRS frame. And what are the use of RRS frame? This kind of frame acknowledges the receipt of a shape and sound frame or group of frames. In this case, the value of N of R field defines the acknowledgement number. And second one is receive not ready, that means RNR. If the value of the code subfield is 10, it is an RNR S frame. This kind of frame is an RR frame with additional functions. What is the additional function? It acknowledges the receipt of a frame or group of frames, and it announces that the receiver is busy and cannot receive more frames. It acts as a kind of congestion control mechanism by asking the sender to slow down. The value of n of r is the acknowledgement number. Then the third one is reject, or we can say it rej. As I have told you, if the value of the code subfield is 0, 1, then it is a rej S frame. This is a negative acknowledgement frame, but not like the one used for selective repeat ARQ, automatic request. It is a negative acknowledgement, can be used in go back NRQ to improve the efficiency of the process by informing the sender before the sender time expires that the last frame is lost or damaged. The value of n of r is the negative acknowledgement number. Okay. So the fourth one is selective reject, that means SREJ. So what SREJ? If the value of the code subfield is 1 and 1, it is an SREJ S frame. This is a NAK frame used in selective repeat arc. Note that the Hdlc protocol uses the term selective reject instead of selective repeat. The value of n of r is the negative acknowledgement number. This is all about the notes regarding the S frames. Okay. So next, the last field is U frame. What is that? U frame. And the unnumbered frames are used basically to exchange session management and control information between the connected devices. What is session management? We have discussed in our OSI model. I hope you go through it and understand properly. Okay, so that is given here. Unnumbered frames are used to exchange session management and control information between the connected devices. That means the total message is is separated by some sessions, and they are smoothly passed towards the receiver end from the sender end by following some controlling mechanism between the two connected devices. That is given here. Unnumbered frames are used to exchange session management and control information between connected devices. Unlike S frames, U frames contain an information field, but one used for system management information, not for user data. Okay. U frames, another important point is here, U frame codes are divided into two sessions. That is PTF bit and suffix after the PTF bit. So together these two segments can be used to create up to 32 different types of U frames. Okay. So again, I may discuss about the control fields. So why we are using the control fields? The control field determines the type of frame and defines its functionality. So what are the different types of frames are available? Three types of frames are available in Hdlc. They are I frame, S frame and U frame. And what are the different functionality are there? I frame having its different functionality, S frame having its different functionality, and U frame also having its different functionality. So how we can easily find that a frame is an I frame? If the first bit is 0, then we can easily find out the frame is I frame. And if the frame numbered, the first two bit is 1 and 0, then we can easily find out it is a S frame. And if the frame number is 1 and 1, then we can easily find out that it is an U frame. So N of S is defined for what? The sequence number, and N of R is defined for the acknowledgement, that is a positive acknowledgement or negative acknowledgement number. And the P by F is given here as pool or final. Okay. So about the S frame, here one new field is there, that is code, and this is called as code subfield. And the code subfield, based on the code subfield, the S frame is divided into 4 parts, that is receive ready S frame, receive not ready S frame, reject S frame, and selective reject S frame. If the first 2 bit of code subfield is 0 and 0, then it is called as RRS frame. And if the first 2 code subfield is 1 and 0, then it is called as RNR S frame. And if the first 2 code subfield is 0 and 1, then it is called as REJ S frame. And if the code subfield is 1 and 1, then it is called as the SREJ S frame. Okay. So here also the N of R is defined as what? Positive acknowledgement number or negative acknowledgement number. And the last one is U frame, and the U frame is having 2 pairs of code subfield. First pair is 2 bit and the last pair is what? 3 bit. Okay. And the segments is totally the total segment is here is as 5 code subfield, and the 5 code subfield can be used to create up to 32 different types of U frames. Okay. What are the different types of U frames are there? 32 different types of U frames are formed by using the 5 number of segments. Okay. So this is all about the notes regarding the control fields on Hdlc. Okay. I hope you understand it well. If you have any doubt, then contact me in WhatsApp. Okay. Thank you.